In this section, first we'll be talking about what are called the distance and midpoint formulas. So just to talk about where this distance formula comes from, and eventually we'll just use this, we'll memorize this. This is the distance formula. Okay, but I just want to show you guys where this comes from first, because it's kind of a complicated looking formula, but it comes from a familiar formula, which is our Pythagorean theorem, a squared plus b squared equals c squared. So if we take a look at this graph here, we've got the point 1, 1, and then we've got the point 5, 4, right? So suppose that I wanted to find the distance between 1, 1 and 5, 4. So I want to find this distance, right? Now, it's a little bit tricky because that's on the diagonal, but note that it is pretty easy to find the distance horizontally and vertically. So right now I've got this right triangle drawn. So initially we're just trying to find the distance between those 2 points. So if we had just, this point, we're trying to find this. So we're going to kind of fill it in and join in so that we create this right triangle. It's easy enough to find the distance horizontally from here to here. If an x value of 1 goes to the right to an x value of 5, that means we have a distance of 4 along the base of that triangle. And then vertically, we have a y value of 1 up to a y value of 4. So those are 3 units apart, right? So we have the vertical height of that triangle. Now we know for a right triangle, we have the formula a squared plus b squared equals c squared. So let's say a equals 4, b equals 3, and then the hypotenuse of this triangle is c. So really we're trying to find c, the distance, right, between those 2 points, that diagonal distance. So because we know a is 4, because we know b is 3, we can say 4 squared plus 3 squared equals c squared. So that's 16 plus 9 on the left-hand side, which gives me 25 equals c squared. Take the square root of both sides, and we end up with 5 equals c. Okay, so we use the Pythagorean theorem to find that distance. Another way of thinking about this is, again, if you just have these 2 points and they're on a diagonal, and you're trying to find the distance between these 2 points, first you can imagine, let me just kind of erase here. First you can imagine finding that horizontal distance along the base of this triangle that you're going to kind of draw in. The difference between the 2 x values, so you could say x sub 2 minus x sub 1 is going to give you that horizontal distance. So in our case, it was 5 minus 1. That gave us the distance of 4. And vertically, we got our distance of 3, but that came from 4 minus 1. We could refer to that as the difference between our 2 y values and our y coordinates, right? So if we rewrite this formula, a squared plus b squared equals c squared, if we rewrite this as x sub 2 minus x sub 1 squared, right, that's our horizontal distance, plus y sub 2 minus y sub 1 squared, that's our vertical distance, and set that equal to c squared for our hypotenuse. Then if we're solving for c, we would take the square root of both sides. Now technically, because we're taking the square root, we would want to put plus or minus, right, sorry, over there. We would have plus or minus, technically speaking. But because c represents a distance, we're not going to have a distance of -5 units, for example. So we can effectively erase that negative, so that's why we're keeping the positive. So this is our distance formula. Distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that's our distance formula. All right, so going forward, you guys are going to have that memorized, but it's just the difference of your x's squared, the difference of your y's squared. You add those up underneath your square root and then take the square root to get the distance. All right, so let's apply this formula now that we know where it comes from. So we've got the points 4, 6, and 5, 9. So let's say this is x sub 1, y sub 1, x sub 2, y sub 2. So my distance is equal to, I'll put a big fat square root sign up there. And I'm gonna use some different colors. So I'm just gonna fill in the minus signs. Notice that it's a plus sign in the middle. All right, so let's see, x sub 2 is 5, minus x sub 1 is 4, and then y sub 2 is 9, minus y sub 1 is 6. So 5 minus 4 squared plus 9 minus 6 squared, the whole thing underneath the square root sign. All right, and filling this in. And I'll change colors just so we can kind of see what's happening. So 5 minus 4 in the first set of parentheses is 1. 9 minus 6 in the second set of parentheses is 3. So 1 squared plus 3 squared. So keeping that square root sign, 1 squared is positive 1. 3 squared is positive 9. Now, be really careful here. What I see a lot of well-intentioned students doing is they're like, oh, cool, 1's a perfect square. Oh, cool, 9's a perfect square. And they say, hey, this must be equal to, you know, the square root of 1, which is 1, and the square root of 9, which is 3, so 4. Yay, I'm so smart. Please don't do that. Underneath the square root, make sure you get one number, one single constant, and then that's when you can go ahead and apply that square root. So here we have square root of 1 plus 9, which is the square root of 10. Now, pretty often, you're going to be asked for both the exact answer and the approximate answer. So for the exact answer, we can say that this is square root of 10, and then we can just use the generic term units, square root of 10 units. If we want to approximate this, and it says in the instructions approximate to the nearest tenth. So in our calculator, we can take the square root of 10, and to the nearest tenth, that would be approximately 3.2. Okay, so a couple of things to keep an eye on before we move forward, and we'll do a couple more examples. A couple of things to keep an eye on. Make sure it's always a plus sign in the middle. I see a lot of students just have a brain fart and put a minus sign there. Note also that whenever we square these differences, they'll always come out positive. So even if I had switched the order of these ordered pairs and I had 4 minus 5 squared, that would be negative 1 squared, which is still a positive 1. Even if I had 6 minus 9 squared, that would be negative 3 squared. That's still going to be a positive 9. And remember to fully simplify under the square root and get one single constant first, and then you can take the square root to get your approximate answer. All right, the exact answer is in square root notation, radical notation. The approximate answer you can type into your calculator. All right, so that's an example of the distance formula. Let's take a look at the midpoint formula. So that's this guy here. And I almost even hesitate to recommend that you memorize this formula, because to me this one's just super intuitive. So to find the midpoint, so for example, in this graph here, we've got the points -2, 1, and then 4, 5. And we're trying to identify the halfway point between these, right? So visually looking at this graph, looking at this sketch, it looks like the midpoint is 1, 3. So that's my guess. But let's confirm this using this formula. All this formula is saying is take the average or the mean of your x coordinates and take the average or the mean of your y coordinates. So add up two numbers, divide by 2. That's the average or the mean between those two values. So here we've got -2, 1 and 4, 5. So if I take my x values, -2 plus 4, and divide them by 2, then I take my y values, 1 plus 5, add them up and divide by 2. -2 plus 4 gives me +2 over 2. 1 plus 5 gives me 6 over 2. And then simplifying, 2 over 2 is 1, 6 over 2 is 3. So that's my midpoint. So it's basically just the halfway point, literally the halfway point between your two starting points. And you're just finding the average x and the average y. All right, so just practicing these formulas a little bit more. We want to find the distance and the midpoint between these given points. And for the distance, I'll put both the exact and approximate. And for the approximate, just like I did before, I'll round to the nearest tenth, so the first decimal place. Okay, so first let's do our distance. So our distance formula. So we've got the difference in our x's and then the difference in our y's with a plus in between. I'll put my minus sign here. All right, so difference between my x's, x sub 2 of 0 minus x sub 1 of -5. So I'll put that in parentheses. Plus, and then y sub 2 is -2 minus 3. So here 0 minus -5 squared is really going to be a 0 plus 5 squared. So that's going to give me positive 5 squared plus, and then next door, -2 minus 3 gives me -5 in parentheses squared. 5 squared is 25 plus, and then -5 squared is also positive 25. And again, remember to add these up. So this gives me the square root of 50. And unlike before, we had the square root of 10 the previous time we used our distance formula. Here we can simplify this square root. There's a perfect square factor that goes into 50. So I'm going to break this apart into square root of 25 times square root of 2, which simplifies to 5 square roots of 2. So the exact distance would be 5 square root of 2 units. So that would be the exact answer if you're asked for that. And the approximate, you can either type in 5 second square root of 2, and that gives you, if we're running to the nearest tenths place, approximately 7.1. Or if you want to go back and type in square root of 50, you can type that in as well because they're equivalent. So either way, you get that approximate 7.1. I'll just make a note that I'm rounding to the nearest tenth. And just round to, whatever you're asked to for the approximate. Okay, midpoint between those two. Again, this is just the average x and the average y. So as an ordered pair, adding up my x coordinates, -5 plus 0 divided by 2, and adding my y's, 3 plus -2 divided by 2. This gives me -5 halves, and then 3 plus -2 is positive 1/2. So that's my midpoint. -5 halves and 1/2. All right, next example. Now we want to find the distance between 2, 3, and 6, -1. So for my distance formula, now watch out, there will be a lot of negatives in this example. So I'm just going to kind of write my skeleton. And it's not a bad idea to use different colors here if that helps you, especially when you've got a bunch of negatives like this. All right, so x sub 2 would be -6 minus x sub 1, so -2, squared plus y sub 2 is -1 minus y sub 1, which is 3, and minus 3. So -6 minus 2 in parentheses gives me -8 squared. -1 minus 3 gives me -4 squared. -8 in parentheses squared is positive 64. -4 in parentheses squared is positive 16. And remember, we're not going to make the mistake of saying, oh, that's 8 plus 4, which is 12. We're going to keep going and add these up to get one number. 64 plus 16 gives me 80. And now we can start simplifying. So first we're going to simplify the radical. I can see that the perfect square of 16 is a factor. So square root of 16 times square root of 5 gives me 4 square roots of 5. So the exact answer is 4 square root of 5. And then the approximate, rounding to the nearest tenths place, I can either type 4 square root of 5, which gives me approximately 8.9, Or I also could have typed that square root of 80 because those are equal. Oops. Square root of 80, there, and that still gives me 8.9. All right, the midpoint, the average x and the average y. 2 plus negative 6 divided by 2, and then 3, plus, go back, 3 plus negative 1 divided by 2 for my average y. 2 plus negative 6 gives me negative 4 divided by 2. 3 plus 1 is 2. 3 plus negative 1 is positive 2 divided by 2. This will simplify to negative 2 and then 1. So that's our midpoint.